All right, welcome to 6.3 Approximating Square Roots. Now, I purposely left this up here for you because some of your homework questions are going to be asking you to tell if a number is rational or irrational. So let's talk about what that really means. So a rational number includes all of these smaller number sets as well. So natural numbers, the whole numbers including 0, 0, 1, 2, 3, 4, 5. Integers include whole numbers that are negative, so -1, -2, -3, and so on. But rational numbers encompasses all of those as well as other numbers like 1.7, 2/7, 1/3, 0.3 repeating, square roots of numbers as well, like 9 and 4, which are perfect squares. So if you take the square root of 9, you get a 3, square root of 4 is a 2. So then that's a rational number. A lot of numbers that you might think of are rational. So what's an irrational number? Well, I'll define it right here for you. A number that cannot be written as the ratio of two integers is considered irrational. In other words, a number that you can't write as a fraction. So pi is a non-repeating, I put that up here, a non-repeating decimal is irrational. Pi is a non-repeating decimal. The square root of any non-perfect square, so the square root of 3, square root of 7, square root of 6, square root of 2, all of those will give you a non-repeating decimal. And if you don't want to take my word for it, you can plug those into a calculator here, like the square root of 3, you get a non-repeating decimal. So you don't see any repetition in here with all these digits. All right, so let's go on and look at this first example. And it simply says, tell whether the number is rational or irrational and explain. So the square root of 14, is 14 a perfect square? Well, in other words, can you take a number times itself and get out of 14? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. No, we jumped right over 14. So no, it's not a perfect square. So the square root of 14, this is irrational, since 14 is not a perfect square. So again, the square root of any non-perfect square is an irrational number. This one, negative 0.3 repeating. 0.3 repeating, if you put in your calculator 1 divided by 3, 1/3. 1/3 is 0.3 repeating. So this is just negative 1/3. So I can write this as negative 1/3. Negative 1/3, well, that is a ratio of two integers. That's a fraction right there. So this is a rational number because I can write it in fraction form. So this is a rational number since it can be written as a fraction. All right, the next one, 5½ could be written as, well, this is 5 is 10 halves, so we have 11 halves. 5 and 1/2. 10 halves and another 1/2 is 11 halves. So again, this is a rational number since it can be written as a fraction. So I just have to copy this. All right, the next one, 0.85, 0.85 is the same thing as 85/100ths. So once again, that can be written as a fraction. So it is a rational number. All right, now let's get to really the heart of this lesson, approximating square roots. So we're going to take a square root of a non-perfect square. The actual value of the square root of 52 is some irrational number. Now, it says we're going to estimate to the nearest integer. Again, integers, those are the whole numbers including negatives. So -2, -1, 0, 1, 2, so on and so forth. That's what an integer is. So it's to the nearest integer. So really, in order to estimate the square root of 52 to the nearest integer, we want to think of what perfect squares are right around 52. So what I'm going to do first, just on this first example where we're estimating a square root, I'm going to just think of all these different perfect squares. So 0, 1, 4, 9, 16, 25. Now, how am I getting all these perfect squares so quickly? Well, what I'm really doing to get a 0 is I'm just taking 0 times 0. To get out 1, I'm taking 1 times 1. To get 4, I'm doing 2 times 2. 9 is 3 times 3. 16, 4 times 4. So notice I'm just taking a single number and multiplying it by itself to get this larger value. That's how I know that this is a perfect square, because there is a number times itself that gives me it. So the next highest perfect square is 36 because 6 times 6 is 36. going, I could get 49 because 7 times 7 is 49. I'll do a few more here. 8 times 8 is 64, so 64 is a perfect square. 9 times 9 is 81, so 81 is a perfect square. Just a few more. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. I'm out of room here. 13 times 13 is 169. So I'm going to stop there. You can keep going forever, but these are really the largest ones that you're going to need in these assignments, I believe. So estimate the square root of 52 to the nearest integer. Well, where does 52 fall in between all of these? Again, these numbers over here are perfect squares. Perfect squares. So where does 52 fall in between? So 52 is going to be right between 49 and 64. 52 falls in between those two numbers. Now 52 is much closer to 49 than it is to 64. It's only 3 digits away from 49, but 12 digits away from 64. So the square root of 52, is approximately equal to the square root of 49, because it's very close to, the 52 is very close to 49, so the square root of 52 is very close to the square root of 49. Well, what does the square root of 49 equal? Well, since 49 is 7 times 7, the square root of 49 is 7. So the square root of 52 is approximately equal to 7. And there's the answer. So that's what we're doing when we estimate these square roots. You just try to figure out which two perfect squares is this radicand, is this number between, which one is it closer to, and then you take the square root of that number, and that's your answer. Okay? So let's try just a couple more of these, and then we'll get to the assignment. All right, so estimate the square root of 33 to the nearest integer. I'm just going to keep copying this over here. All right, so if we're looking for the square root of 33, well, 33 is very close to 36. It's right between these two perfect squares, 36 and 49. Oh, excuse me, I'm looking at 33. Between 25 and 36, it's 8 units. 33 is 8 units away from 25, but it's only 3 units away from 36. So it's very close to the square root of 36. It's closer to that one than it is to the square root of 25. So the square root of 33 is approximately equal to the square, that's why I'm using that squiggly equal sign, the approximately equal to symbol. Approximately equals the square root of 36, which is 6. So the answer, the nearest integer, is 6. Example number 4. On this one, we have a negative, but that's okay. We're still going to be looking for the square root of 7. So which two perfect squares does 7 fall between? Between 4 and 9. It's closer to 9 than it is to 4. 7 is 3 units away from 4, but only 2 units away from 9. So the square root of 7 is approximately equal to the square root of 9. Now we have a negative out in front of that square root symbol, but that's okay. If I put a negative in front of this square root symbol, I just need to put a negative in front of that square root symbol. So the negative square root of 7 is approximately equal to the negative square root of 9, which equals negative 3. So the answer to this one is negative 3. All right, so let's get to the assignment. So as promised, I am going to continue to do the odd problems with you. So let me pull up your assignment here real quick. We are on pages 249 to 251. And on 249, we are looking at number 1. All right, so what is the difference between a rational number and an irrational number? Let's just go right back to the definition for number 1 and say a rational number can be written. I'm just going to pull off this definition right here. An irrational number cannot be written as the ratio of two integers. So a rational number can be written as the ratio of two integers, while an irrational number cannot. That's it. All right, number 4, you are responsible for. So which number does not belong with the other 3? I'll give you a hint here. 3 of these are rational. 1 of them is not. You need to figure out which one is not rational. In other words, which one of these 4 is irrational? That's the one that does not belong. Looking at number 9, 9 through 21. All right, here we go. Tell whether the number is rational or irrational and explain. All right, so number 9 is, don't forget to explain on these. Number 9 is rational. This number is rational since it is a repeating decimal. And all repeating decimals can be written as fractions, so that implies that it is rational. All right, number 10 is up to you. Number 11. Number 11, let's see what we've got here. This is not a perfect square. So number 11 is, this number is irrational since it is a square root of a non-perfect square. Number 13, this one you could write as a fraction, therefore it is rational. Number 13. This number is rational since it can be written as a fraction. If you want to get really fancy, instead of saying as a fraction, you could say as the ratio of 2 integers. All right, and then number 15. Number 15 is one of those where you correct the error. Right here they said the square root of 144 is irrational. The error there on number 15, the square root of 144 is rational since 144 is a perfect square. So 12 times 12 is 144. 144 is a perfect square. So it's the square root of 144 actually equals 12. That's a rational number, not irrational. All right, moving on to the next one, we have to get into number 17. Here's the Venn diagram. Place each number in the correct area. Now, I am not going to be able to give you your answers. But for my answer, my age, I'm sorry, this will work for any age. So it says your age, but it works for any age of a person. So your answer would be the same. So your age, number 17, part A. Number 17, part A, my age is what kind of number? Well, if I tell someone that I am 30 years old, where would the number 30 fit in? That's a natural number. So my age, 30, I'll just put 30, is a natural number. Now if I were to say, oh, I am 30.7 years old, I'm not going to say that 30.7 is a natural number, so then I'd have to go out to the rational numbers. So it depends on how you describe your age. Usually you wouldn't say you're 30.7, or in your case maybe like 15.7, but you could say to someone, oh, you're 15 and a half, and then you're not in the natural numbers, then you go out to the rational numbers. So it depends on how you describe your age for that one. But since I said I'm 30, that's a natural number. All right, part B. On part B, it says the square root of any prime number. The square root of any prime is going to be an irrational number. I'm going to write that out or type it out. The square root of any prime is an irrational number. And then part C, the ratio of the circumference of a circle to its diameter. That's actually the definition of pi right there. So part C is really asking you to put pi somewhere on that Venn diagram. So pi is, as we know, an irrational number because it is a non-repeating decimal. So for part C, the ratio of the circumference of a circle to its diameter is pi. Pi is an irrational number since it is a non-repeating decimal. There we go. So you can't write it as a fraction. All right, moving on. We had to go to 21. So number 19 and 21 I have to do with you, and then you'll have to do the evens. Number 19 is the square root of 685. I'm happy I'm doing this one with you. So number 19. Number 19, the square root of 685. So I said, when I was doing my lesson, I incorrectly said that, oh yeah, these will be enough. Well, 685 is greater than 169. So we actually have to go a little bit farther than that. My apologies. So I'm going to copy this over. There we go. I'm going to copy this over to here. So we are not yet up to perfect squares that are big enough to fit 685 between. But how do I find more? Well, just keep multiplying higher numbers by themselves. So I'll do 14 times 14, 15 times 15, 16 times 16. And I'll just keep on going. So, I mean, really, you could just take out a calculator and just keep multiplying a number by itself until you get a number that's bigger than 685. But I'll just write these down here. So 196. Next one's 225, 16 times 16. 16 times 16, that's 256. 17 times 17, that's 289. So these are going to take a little while here. So what I am going to do is actually skip ahead, because I know 20 times 20 is 400, and that's still not big enough. So I'm going to go 25 times 25 and see what I end up with. 25 times 25 is 625. And then let's go with 26 times 26, because I'm getting close. 26 times 26, 676. So it's got to be the next one, 676. And then 27 times 27 should do it. 27 times 27 is 729. There we go. 729. All right, so 685 is right between these two perfect squares. Which one is it closer to? Well, 685 is only 9 units away from 676. If I add 9 units to that, I'd get 694, and that's definitely not 729. So yeah, so it's much closer to this 676 than 729. So I'm going to say this one is approximately equal to the square root of 676, which equals 26. So my answer, number 19, is 26. All right, moving on to the next odd problem. Again, we had to go through 21 for these. So 19, 21 is the next one. The last one in this little section that I have to do here is negative square root of 105. 105 is very close to 100. So if I'm looking at all my perfect squares that I've written on here, it's very close to 100. It's between 100 and 121, but it's closer to 100 than 121. So this one is approximately equal to the negative square root of 100, which is negative square root of 100 is 10. So negative 10 is the answer. All right, moving on. Number, we didn't have to do 23, so we have 25, 26, and 31 to go. 25, 26, and 31. All right, so 25, you have to do 26, and then we have 31, 25 and 31. So number 25. On 25, it says, which number is greater? Is the square root of 20 or 10 greater? Well, the square root of 20 versus 10. The square root of 20 is approximately equal to what number? Square root of 20 is approximately equal to, if I look at my perfect squares here, get that off of here. All right, so the square root of 20 is right between 16 and 25. 20 is right between 16 and 25. It's closer to 16, so this is approximately equal to the square root of 16, which equals 4. But either way, it's between 4 and 5. So the square root of 20 is between 4 and 5. So is that one greater, or is 10 greater? Square root of 20 or 10? Well, if this one is approximately 4, somewhere between 4 and 5, then 10 is obviously greater. So this one says which number is greater. I'm going to type my answer out. And I'm going to say 10 is greater than the square root of 20, since the square root of 20 is between 4 and 5. All right, I think you can get these out of the way now. All right, so that's the answer to number 25. And the last one I'm going to discuss is number 31. On 31, playing some Foursquare here. I cannot wait to play this game this summer with my kids. So here we go. The area of a Foursquare court is 66 square feet. All right, 66 square feet is the area. So it's a square. So S times S, each side length here is S. S times S gives me the area. It's 66 square feet. So here's what I'm thinking. It's a square, so area is length times width. Since it's a square, it says both of these length and width are S, so area is S times S. S times S is S squared. Well, it tells me the area is 66 square feet, so I'm going to plug in 66 for the area. Now it says estimate the length S of one of the sides of the court. So all you have to do is undo this square. And we do that by taking the square root of both sides. So I need you to finish out this problem. This square root and square will cancel each other out. We end up with S equals the square root of 66. I need you to tell me, or please estimate the length of one of the sides of the court. Now, given the material in this section, I want you to, I'm going to just put my instruction on here. I want you to estimate the square root of 66 to the nearest integer, and that'll help you practice estimating to the nearest integer. Okay, so you have to finish up 31, otherwise you do have to do all of the even problems assigned in this assignment, and I also expect that you are taking down notes as I go through these problems with you, so please do that. I'm trying to give you some free answers here and help you then complete the other problems. Now, a lot of these were odd problems, so the assignment you actually have to do is very short. So again, I expect that you are copying down at least my work here. And then for future assignments, try to challenge yourself a little bit. Maybe pause the video and try to do some on your own, and then watch the explanations that I give after the fact and compare it with yours. I think that will help you a lot more than just copying down problems. All right, if you have questions, let me know. Thanks.